Hello, I'm Ryan Riley, Senior Pilot and Analyst with GRYFN. Today, we'll be walking through the basics of setting up and processing your remote sensing data in GRYFN Processing Tool. To begin our processing workflow, we'll start by creating a GRYFN Raw Data Bundle, or GRAW for short. Data bundling copies all raw sensor data into a clean and consistent folder structure the software can easily read and search through. It will also create necessary metadata required for processing. To begin bundling, we'll choose the Bundle Data tab, then Create New Bundle. On the first page of bundling, we'll select our system's boresight calibration file, optionally, a processing extent file which will automatically trim our data products to a predefined area, and then select our raw data source. We have two options for selecting our raw data source. Single source will search through the input directory and any subdirectories for the proper file extensions associated with each sensor listed in the boresight calibration file. It will then distribute these files to the appropriate sensor folders. Multi-source bundling allows you to select a separate directory for each sensor data type. This is useful if you have raw sensor data stored on separate drives or in separate directories. In File Explorer, you can see that all of our sensor data is stored in subdirectories of a single directory, so we'll use single source bundling. If multiple flights of data need to be orthorectified together, we could add those additional flights here with the Add a Flight button. Next, we have a few optional fields where we can keep track of the pilot, location, and weather information, or any other general notes from the mission. Finally, we'll name our bundle and select the directory where we want to save the bundle. Press Create Bundle to begin the bundling process. After our data has finished bundling, we can click Open Data Product to view our GRAW bundle. Here, we'll see all the available raw sensor data split into proper subfolders with relevant metadata and log files created. To begin processing our data, we'll return to GRYFN Processing Tool and select the New Job tab. In this tab, we will specify the processing configuration for our GRAW bundle through the use of a pipeline. We can store various pipelines on this page to use with different payloads or to generate different sets of products with varying parameters. For this demonstration, we'll use a pre-built pipeline to process GNSS, LiDAR, V-near hyperspectral, and high-resolution RGB data together. Let's take a look at some of the customizable parameters of our pipeline. Our pipeline has a separate task setup for each sensor type. You can add tasks by hovering over the New Task button. Our GNSS task allows us to specify the processing mode and datum. Using the Smart Base mode, we'll process our GNSS data by creating a virtual reference station at the survey location by triangulating fixed base stations in our area. Our LiDAR task allows us to specify the range and azimuth angles to process, and we can create a few products as well. For this mission, we'll create a digital service model, which will be used as elevation data for other products later, as well as a point cloud. Next, let's look at our V-near task. Our V-near products require elevation data, so we've selected our LiDAR DSM. As for our products, we'll be outputting a V-near spectral mosaic using the new GSD base resolution calculation. GRYFN Processing Tool will calculate the ground sampling distance for this sensor based on the sensor parameters in the boresight calibration file, as well as the altitude of the flight. Finally, let's look at our RGB task. Our RGB task allows us to adjust the parameters of the RGB image feature matching. For most use cases, the default values are good. Let's take a look at the products we'll be making. We have an RGB mosaic being processed at 7 millimeters, which, like V-near, requires a digital surface model. We've selected our DSM here. We will also be outputting a colorized point cloud which will take the combined point cloud from LiDAR and colorize it using pixels from the RGB mosaic. Let's go ahead and save our pipeline. To start a processing job, we'll select our pipeline and then select our GRAW bundle. To process the GNSS data from the survey, we need to select the range of GNSS files to process. For our veneer data, GRYFN Processing Tool will automatically convert our raw data to radiance. To convert our radiance data to reflectance, we must perform spectral target selection, which allows GRYFN Processing Tool to employ an empirical line method correction. Let's select our spectral target DHR file. Next, we'll find the data cube with the targets visible. Click Draw Target Bounds, and we'll measure each target. After we've measured each of the 3 reflectance panels, we can save our measurements and submit the job. At this point, the data will process and will return when it's complete. Our processing is now complete. In total, this job took 88 minutes. We can click the button above the processing log to open our GPro folder and view our products. All of our products use industry standard file formats so you can view them in your GIS software of choice. Let's take a quick look at these products before we wrap up. In Cloud Compare, I've opened up our LiDAR point cloud. As well as our colorized point cloud. In QGIS, we can see a satellite base map, our LiDAR DSM, our veneer hyperspectral mosaic, now overlaid with survey points from an RTK system, and finally our high-resolution RGB mosaic. To summarize the workflow in GRYFN Processing Tool, we started by creating a GRAW bundle, then went to the New Job tab to select a pipeline, then selected the GRAW we wanted to process. Finally, we submitted the job, and after some processing time, got to view our data products. We hope you found our GRYFN Processing Tool Quick Start Guide helpful. If you have any questions or would like to learn more, please visit our website or reach out to our team. We're always here to help.